Okay, in this video, we're going to look at combining functions. Okay, so for some general stuff for this, if we want to do addition, then we're just going to add the two functions together. Subtraction, we will subtract the two functions. We do need to be careful with that one, making sure that we set up our subtraction carefully. For multiplication, we're just going to multiply. And for the divide, it's going to look like straight division. We do have to add in that extra notation here that g of x cannot equal 0. Okay, so we're going to be working with the same two functions over and over here. Okay, and I'm going to pull them the first time, and so I'm going to get these over here on my other board. Okay, and we're going to look at doing the combinations here. Okay. And we will worry about finding the domain of each one. So this is going to go through add, subtract, multiply, and divide as we're processing here, okay? Okay, so here's our functions. So the first thing that they want us to do is f plus g, okay? Which is we are quite literally going to just add these two together, okay? We are going to combine, okay? I am going to clean this up and just put it in more of a traditional order. Okay, so this is my combined function. This is my added function. So that is f plus g of x. For the domain of this, okay, x minus 5, there are no problems with that. There's no square roots, there's no fractions. Over here, again, we have no square roots, no fractions. So the domain is going to be all reals. You may also see this denoted negative infinity to infinity. Okay. Now, I'm going to scooch down and we're going to do f minus g of x. Okay. Now, this is where we need to use a set of parentheses, similar to what we saw when we did our difference quotient. Okay. We're going to use subtraction here. We're going to use a set of parentheses to make sure that we're very, very careful with this. This is x minus 5 minus x squared plus 1. We are going to distribute that negative through the line. And again, we'll just kind of clean this up. Plus x, negative 5 plus 1 is going to be negative 4. Okay. And again, for this one's domain, I don't have any problems. So this will again be all reals for that one. So then we'll get into multiplication. Okay, I got rid of mine. Okay, so if they want us to do f g of x, or the multiplication here, we're going to do x minus 5. And again, I'm going to use parentheses here to keep them together. It's also going to help me sort out my math here. This feels very much like FOIL, which is what it is. So we're going to have x cubed minus x minus 5x squared plus 5. Again, we can clean it up just a little and get it in that kind of traditional looking pattern where we start with the biggest powers of x and work our way down. Again, with the domain for this one, again, there's no square roots, there's no fractions, there's no nothing. There's nothing weird or funky in that multiplied setup. So that's going to be what that is. And then we've got division. This is going to be x minus 5 over x squared minus 1. Now, here's the deal. We have to make the statement right now. X squared minus 1 cannot equal 0. Okay, we have to make sure this bottom. Now, we can sort this out. Square root on both sides. So now then, for our domain, we've actually already stated what our domain is going to be. X cannot be plus or minus 1. And again, you can separate those off. Now, occasionally with the division ones, okay, and I'm going to create one here that would do this, okay. let's say that we had some sort of something that had like an x minus 2 on the top. And that's all on. Now, we're going to be able to cross these two off, okay? But when we deal with the domain, we still have to make the statements, even though that's going to cross off, you still have to have both pieces. Okay? Because the way the rule was stated, it didn't say the reduced form of this denominator cannot equal 0, okay? Here, all this is going to do is make the math easier to work with if I'm having to find values. But I still have both of these values were off limits for our domain.